Hello, everyone. Welcome to this episode of Z.I.P Talks. Today, we are with the number one ranked team in the world, 19006 AiCitizens, and today we'll be talking about their robots journey this season and their team sustainability. My name is Mohil. I'm the co-captain and outreach lead of Team Z.I.P Ties.
My name is Arnav. I'm the build lead on Team Z.I.P Ties.
My name is Anish. I'm a rookie builder on Team Z.I.P Ties.
And hello, we're Team 19066 AiCitizens. My name is Petru. Most of the Discord people know me as Peru.
Hi, I'm Irina, and I'm the PR leader of the team.
Hi, I'm Rami, and I'm the driver of the team.
Nice. So to sort of start off the conversation, when you guys saw the season for the first time this season, what were the main things that you guys wanted to accomplish with your robot, and what did you think about doing with it?
When we saw the next moment before the kickoff, we knew we wanted to make an extendo, and throughout the season, it proved to be a pretty good choice. Having really high ranks in all of our competitions, and being one of the fastest robots on the field. But choosing to do an extendo didn't only have the good part of it. It had some downsides too, especially when it came to the autonomous. We had problems with the friction the extendo made the chassis have. And now we implemented some new mechanisms on basically just optimized our extension, and now most of the friction is removed, and the robot is way better optimized than it was at the start of the season.
That's great to hear. With Extendo, or with the extending slides, how many slides do you guys plan on implementing? And then what was the main reason for implementation? I don't know if you talk about that.
I'm gonna talk about this one. So earlier on in the power play, this was the season power play when we first bought Misumi's, and we found out about drawer slides and whatnot to remove friction. And after that, we decided to maybe buy a few SARC 230s and 240s because maybe we could do an extendo sometime in the next few years. But I mean, it proved to be the next season. And our extendo is made up of two 240s and a 340. And this allows us to extend up to 85 centimeters, although we extend only to 77 uh, because we have a few more friction problems right at the end of the last 10 centimeters.
Yeah, I remember last year for power play, just like you guys had the extended this season, we actually had 6 stages of the SAR 230 slides to grab up from the stacks, and it was really efficient, but we had lots of problems with stringing it and because of the gravity pulling it down the pulleys. How did you guys avoid getting the string caught over the pulleys and other challenges that come with extendos?
So we did have a lot of problems with stringing. Well, mainly because this is the first season we tried extendo, and we didn't know what was good and bad. And initially we guided the string a lot, and that proved to be good because we only have one motor on the extendo, and it was necessary to guide it a lot onto the single spool. But because we used a really thin string at the start of the season, and our pulleys weren't optimized, and string could easily jump off, we had a lot of problems with the stringing and blocking. And we tried a lot of string diameters, a lot of guides, more protection, more walls, and we ended up using I think it's a 1.6 millimeter rope right now. It's not the thinnest, but we haven't really had any problems with it jumping for the past 2 to 3 months now. So it proves to be good when it comes to reliability.
Yeah, I know at least with us last year, one of the biggest problems we had in power play when we were trying to do the extending slides was sometimes they'd just get unspooled just because of how many slides we're controlling with our motors.
Yeah.
And what are some like tips or advice you'd give to teams that want to try out the extending slides with more than 3 or 4 slides on each side?
It's a good idea to first think about how much extension you actually need a lot, like before you make the CAD and the models and whatnot, because some may overestimate how much they need and end up like having other problems. For example, I've seen teams that extend a lot, retract, and then have to wait another 1 second while not moving just to the transfer process or something else. So it's a good idea to optimize the extension too. And besides that, I think I, it's a lot of experimenting that needs to be done with slides to test what works and what doesn't when it comes to guiding, when it comes to stringing and whatnot. And for example, we have a continuous string right now, and it's the only way we can extend the slides because we have different slides. It's we could have done cascade if we had like only 240s, and that would have probably been better because it would have allowed us to have less friction since our string is really large. 1.6 millimeters fills up the spool really quickly and changes diameter a lot, and that stretches out the spring and makes the motor harder to extend. And like that's the main problem with diameter changing on the spool.
So with the diameter changing on the spool, how were you guys able to fix that?
Uh, well, we didn't uh, completely fix it. What we did was make the spool, like the walls of the spool, way larger, and we chose different diameters of strings until we ended up on the 1.6 right now, which has a lot less problems than what we used to have before, but doesn't unspool itself.
Um,
Oh yeah, just moving on to like your actual intake assembly on your extendo. I had a few questions about it. Like when you guys first, like Mo was saying, got into the season, how did you guys know that you wanted to do an active intake versus a claw?
Rami?
The active intake seemed way more reliable for the center stage season, and it was way easier to control because we only have one driver in the team, and we had to make room for very much error, and that's why we use an active intake.
Yeah, and Claw needed a lot of precision, and we wanted to have as much freedom as we could when it came to tolerances and whatnot. And besides that, active intakes can prove to be faster since you don't spend as much time on lining and other things. And it was also just way easier to create a transfer for, and we didn't have other problems with packaging.
Yeah, and like talking about your intake, I think you guys have like a like a count like a roller on the bottom of your intake to kick up the pixels. So how were you guys able to implement that on your robot? And do you guys face any trouble with it this season?
We actually don't have a counter roller on the intake.
Okay.
It's just a ramp for the pixels.
Okay. So
Have you guys considered using a counter roller? Because I know at least a lot of teams in Florida use the counter roller to like, kick it up. We actually tried implementing it, but we couldn't figure out how to get like a thin enough diameter at the end of the belt in order to put the wheels.
When we saw a lot of teams using a counter roller at our regional championship, we thought about doing it, but we didn't have enough time to implement that because it meant changing a lot of our intake, since it's basically at the level of the ground.
So the intake was designed to be as short as possible and guide the pixels directly in. and adding a counter roller would have made it longer, and we are already sitting at close to the limit in length. And the thing is, the counter roller, it is it is really good. It improves the reliability and intake time, but it does provide a challenge when it comes to packaging, as you said. And I've seen teams that use like a GT2 belt and a gear system, or a wrapped around O-ring, but both of those were really large, and we are already like sitting at close to 1 centimeter side to side with the intake and the drivetrain plates, and it would have been a great challenge. And we didn't want to sacrifice our time spending it on the counter roller when the intake was already working quite good, and we decided to spend the time hyper optimizing other systems.
Yeah, I think that's something that we were trying to think with too. Is like with our intake, we don't use slides for our intake, but we just wanted to optimize it as much as we can, just to improve our driver's ability to control the pixels, especially with like the stacks. Because I know that's like a lot of thing. That's a thing that teams are trying to do so they can work better with their alliance partner. So speaking of which, what are like some optimizations or things in your robot that you use to work best with your alliance partner?
Rami?
So like,
Uh,
it,
I
Okay,
think I'm gonna
okay.
speak. So we we spent a lot of time making the strategies, a lot of different scenarios and testing, and like coming up with problems and finding
And
solutions.
in the end, we ended up with like, I think, over 50 scenarios for every pixel placement after the autonomous. And now we made some improvements on the bot, adding a new degree of freedom that helps us build up the strategy way easier and consuming less pixels with the wrist on.
Yeah, so after the national championship, we saw that we needed a wrist to be able to use and place mosaics pixels to make mosaics way easier, and that was the main modification we did, and that does help a lot when it comes to playing with teammates, because we can now play with a larger variety of teams. Since before we had to play with teams that could help us make mosaics way better, since we had on only horizontal claw. But besides that, we did try to find trajectories in both autonomous and teleop period, so that we wouldn't intersect with our teammates. We could be as fluid as possible and not interact, but at the same time collaborate on the mosaics and the other parts of the game.
okay. Yeah, I think even with our team, we have a sort of like a bucket system, so it's sort of similar to Tenno's, 1592 in Romania. And what we even something that's like a bit different from ours and theirs is like, I think the individual dropping of the pixels, like how we do that's a bit different. But something that we realized with our robot is that we wouldn't be really efficient with making mosaics, as well as crossing the set line, just because now like, at Worlds you're gonna be with a lot of teams who can place pixels really fast on the board. So creating mosaics and then building up to the height together is really important. Um, so talking about your wrist for your outtake, did you guys like consider using like a differential arm, or is it just like a arm that moves to certain positions?
So we did think of using a differential arm right after the national championships, but then again, it was another complete redesign of the outtake, and we didn't want to do that and lose time on other places. So we simply just put a new claw on on the old arm, and we managed to make the claw the same size as the old one, so that we didn't have to change the length of the arm and repair the transfer after that. And it's like the simplest shape, the simplest form of a wrist you can find. It's just a servo mounted at the end of the claw and between the claw and the arm, and that was kind of it, with preset positions. I think it's about like 9 positions to place pixels.
Okay, so, like with these positions, like, did you guys like when you were creating these like nine positions? Because nine positions for placing pixels seems like a lot. What did you guys sort of consider or take into factor with each of these individual positions?
We have a 60-degree rotation position for completing mosaics. We have a vertical position for building up to the third set line, and another 60-degree position that is like uh, it continues after the 91, basically moving the position of the pixels, turning them backwards. And then we have the 180, close to 180 degrees position if the human player places the pixels wrong.
Yeah, and then one thing I wanted to ask is a big part about this year's challenge specifically is building as compact of a robot as possible. Obviously, you have to travel under the stage door, travel under the trusses. So, how did you guys come up with like all of these high feature sub assemblies, like your intake, your outtake, and how do you make them compact so that it all fit in one tight package?
So an interesting part about this one is that I want to say this is the first year that we did CAD for the comp bot, and that did a lot when it came to packaging, making the bot as small as possible. And a really important, well, limit we established at the start of the season was, of course, the 12-inch height limit. But at the same time, we noticed in power play that smaller bots were able to move way easier between the poles, and we thought of it the same way when it came to the truss. Going through the two legs that sit at like 23 inches side by side, it was easier if the bot was slimmer in width. And the length, there just wasn't a limit because there isn't any sort of challenge that would impose such a limit. And so we did manage to make the robot under 12 inches. I think it's like 11.25 inches, since the Misumis are the tallest things and they're mounted at 60 degrees. And we also managed to make, I think it's a really slim, maybe one of the slimmest extendos in this year. It's 32 centimeters wide, and this allows us to go through the truss way easier and make more complicated movements more fluidly. And it proves that right in the teleop period where our driver doesn't focus as much on aligning between the truss legs, he just like goes way faster through them.
On your drive base, so for your mechanical mules, what RPM motors do you guys use?
I want to say I recommend teams to calculate this because initially we underestimated the weight of the robot by about 3 kilograms, but we did choose in the end to use 435 RPM motors geared 1-to-1 to the mechanical wheels. We use go build a 96 millimeters, and that proved to be a good balance when it came to max speed and both acceleration. Although maybe going a bit lower in RPM would have improved acceleration, and I've seen it is actually required in this game to have a high acceleration because of the small uh, jerky movements.
Mm-hmm. And then do you belt all your motors or um,
Yeah, so we built all of our motors because in power play we did have problems aligning the miter gears, so we figured why spend time aligning the gears when we could do it on other mechanisms. So everything we have is either belted or using pinion gears.
sort of switching towards your outtake on the robot, going into the season and sort of its evolution throughout? What were the main things that you wanted to accomplish with your outtake, and what were like sort of the biggest changes you made from now to the World Championship?
So initially, the first two things that we designed were the intake and the claw, and we wanted to use the claw because it was like really short, really small, packaged nicely, and it was very versatile. And after that, we decided what was the best way to use the claw with an arm. And we have a counter springed 25 centimeter polycarb arm. That's the polycarb plate is 4 millimeters thick, and we needed a counter springing because at such a high length the inertia would break the servos. We used two Axon Maxes, and this proved very good and efficient because it can like rotate 180 degrees in about 0.3 seconds, and besides that it is very versatile and precise. It allows us to have it at 60 degrees behind the robot or even flat horizontally, and lets us place even when there's like 2 pixels length between the robot and the backdrop, so we don't have problems with a lot of pixels being dropped in front of the backdrop, and it allows us this high speed control.
And then I think you talked about your 9 positions that you have for placing for mosaics. Do you have any other sort of optimizations or things in your code that you use to optimize pixel placement and overall driving across the field?
We have for optimizing the driving of the field, we implemented a lot of automatizations on all of our mechanisms, especially when it comes to the intaking of the pixels. Due to the fact that we only use one driver, we had to map all the buttons on only one controller. So for the extension with intaking, we only use one button, and after the pixels are gathered by the intake, they are detected by two sensors, and at that moment the extender retracts and the intake is prepared for the transfer. On the next step, with only one button, the whole transfer is done, and then with the same button we can adjust the height of our lift, and the final button that is used for placing the pixels just opens either both of the claws or only one of them, one by one, and retracts all of the systems being prepared for the next intake. Between the nationals and this point, we implemented the wrist, and that added 2 more buttons for controlling all of the different positions of the wrist, of the preset positions. And then there is only, I think, 2 more buttons, one for launching the drone and one for doing the hang in the end game.
Yeah, so I mean, you talked about all the automatizations you guys had. What kind of sensors do you guys have on your robot in order to make all these optimizations in both teleop and auto as accurate as possible?
Right. So we do use 15 sensors in total. I can go through each one. We use the current sensing a lot, encoders, of course. And we do have the 2 sensors that Rami mentioned on the intake, both being I2C 2-color sensors from Rev, the version 3. And besides that, we use the IMU and the voltage sensor to compensate for voltage on all systems that use PIDs. And yeah, we did automate everything. So for example, just taking the pixels off the ground and placing them on the backdrop, I think it's like 3 buttons and that's it. And we did use encoders because on our lift, okay, we do have 2 motors because we climb with it too. They are 2 435 motors with a 32 millimeter spool, and they're not mechanically linked, which is a bit problematic. So we did have to sync them in software, and that's why we do use two encoders just for the lift, another one for the extendo, and we do bulk read both hubs to manually to save a few loop times.
Yeah, that's great. So how do you use some of these sensors in auto? Just looking at your finals match for the Romanian National Championship, I saw you guys are able to just sweep the pixel stacks until you got the pixels you guys needed. Like, what kind of movement algorithms do you guys use in auto in order to like know when you where you should look for the pixels and like when you get them?
Yeah. So I want to start with the localization of the robot first. We use three module odometry system with IMU, and we do the normal three wheel calculations, and we use the IMU on a separate thread to reset the heading due to possible heading drift problems created by the odometry. And after that, we use our custom pure pursuit algorithm. It's more of a non-profiled Bezier follower, and we are able to have the robot follow curves and keep that continuity after each one. And that, alongside the command-based system and the two intake sensors, lets us know whenever we have the two pixels inside the intake, when to move and where to move. And we don't have to wait for trajectory generation. We do on the fly because it's just pure pursuit, and that allows us to have these more complex paths that Roadrunner would be harder to do, like oscillating back and forth at the stack, or just ramming it, and until the two pixels are in took, you just strafe.
Yeah, we use Roadrunner actually, and we found a bit more success with it compared to Pure Pursuit. But you know, we plan to look at Pure Pursuit in the future. I think we tried to make like our own thing instead of Roadrunner just because of how inefficient it is when, as you're saying, like an auto, but it was a bit more accurate for us compared to Pure Pursuit. And sort of talking like at least we've talked about teleop and auto now, like a bit more on endgame. So could you walk us through like your drone launching design, your paper airplane itself, and like your hanging mechanism?
For launch, the paper plane mechanism was based on Petri. If you can help me, what team?
So we did take inspiration from Bluebot builders, and
Right.
we
Basically, it's the drone launchers they made public, but slightly modified by us to fit for our custom paper drone and to be more adjustable when it comes to the power of the spring. Initially, we tried to use a normal surgical tubing for springing the drone launcher, but it proved to be really inefficient and inconsistent. So we switched to normal elastic bands, and we slightly modified the drone launcher so we can fit the elastic bands better. And for the hanging mechanism, we use it's basically hard mounted onto the slides. There are just two hooks which we use the final element analysis.
finite element analysis so that we could test out the hooks because they are 3D printed. And I mean, we do use PETG carbon fiber to reinforce them, but we wanted to make sure that even after the infill is done, they wouldn't break. And we simulated them, I think, up to 100 kilograms, and they still wouldn't break. And that was pretty good because that way we didn't have to add another mechanism for hanging, packaged better and less weight.
Mm-hmm. Yeah, we do a sort of similar thing with our robot. Our intake, or sorry, not our intake, our outtake and our hanging mechanism are together just so that we don't need to waste more space and weight on the robot. And sort of talking about your plane design, what type of design do you guys have? Did you guys like sort of cut it out, or did you use like a traditional paper airplane?
We went. Our paper drone went to way more iterations than it should have. We tried using boomerang paper planes, and they were good. They had a really good trajectory, but it was really inconsistent, and it was affected by any manufacturing mistake and affected by the atmosphere of the room. We tried to do normal, like the most basic paper plane that every kid knows to do, and that one proved to be the best. Having a really consistent trajectory, not being affected by the small errors when you make it, or the current in the room.
Yeah,
and there in the room, and it was pretty good. And at the national championship, I think we hit like 3 zone ones and 3 zone twos, something like that. It was pretty consistent, and that's what we wanted from it.
That's really good to hear. Yeah, we use like a spring-loaded drone launching mechanism with a 3D printed roof on top, and then we also planned on sort of mitigating the size of the paper airplane. Arnold could actually tell you a bit more about it.
Yeah, so we just tested a bunch of different springs and a bunch of different plane designs, and we ended up on a design that was very compact, and the drone launcher is compact too. That way, it doesn't take up much space on our robot. I've seen a lot of teams with like these big rectangles in order to shoot just a tiny plane, and we saw that as they were very consistent, but we noticed that it could be more compact. That way, it takes up less space on the robot. And we just tested a bunch of different springs until we found the optimal shot length.
Yeah. I do want to say I don't think I like the Bluebot Builder's airplane launcher, drone launcher, because it is really compact. It does package nicely because it's so slim. But at the same time, the one reason I don't like it is that reusing the airplane doesn't really do nicely, because once you place it in, it does bend the wings a bit, and because of that, reusing the airplane would be a mistake, and it wouldn't fly the same amount. It would be inconsistent. And I do like the T design slots better because they don't put any other bending forces on the airplane, and that way they can reuse the planes and they're like more consistent. There's less friction. But we did face problems when it came to packaging, so we ended up using the Bluebot Builder's design.
Yeah. Sort of like overall with your robot, what are like the biggest challenges that you faced, either when designing it or coding it, and how are you guys able to overcome these challenges?
Being transparent, the biggest challenge was the extendo itself. When it came both to having it mechanically sound, have no problems, have less friction, and actually do something, improve our cycle times, and be able to be used in auto. And our initial problems were with the stringing, with the friction, and then because of the sag, we didn't have options other than like actually go build a no flange bearings, and that proved to be good when it came to extending, but very bad when it came to strafing or rotating. So after we actually managed to put Omnis on, we started making the auto, and that was problematic again because uh, initially we used Roadrunner, and when it came to feed-forward calculations, it went bad because of the friction, and that would turn the robot a lot when strafing, and that was not favorable. So in the end, that's why we moved to PID on the robot and pure pursuit after, because having no feed forward makes it more aggressive. Want to care less about the system and more about just the error itself, and that helped a lot since even with a lot of friction in the extendo itself, we were still able to get like I think within 1 degree, 2 degrees of the target heading, and that proved to be way better when it came to auto.
Nice.
Yeah, but so with all these extending mechanisms on your robot, how do you guys manage your wiring? How do you keep it from snagging, from getting caught, unplugging? Just things like that. Like I know for our robot, both last year and this year, with both the far extensions, we had lots of problems managing the wires and making sure that they wouldn't get caught in anything. Last year, we actually used cable drag chain on our intake slides and our outtake slides, but this year, because it's based on a robot, we couldn't implement that. How do you guys tackle this challenge?
So we did, and we do use drag chains too. Um, we thought of multiple ways of doing it. We looked at gluten-free videos, CookieBot videos, saw how they did their cabling, and while it was really reliable, we didn't like the idea of just having the cable loose in the air on the ground. So we did want to constrain it a lot better. And looking at other teams like Wolfpack Machina, Road 2D2, 17962, we saw the scissor extension, but we didn't have enough beams in our club, and so we resorted to another method that we did use back in Fred Frenzy when we did have another extension using a drag chain. And we did guide it a lot to be useful, and it proved to be really reliable, packaged quite nicely, and was the slimmest we could make that was still able to do quick fixes, repairs. And on our lift itself, we used the loop method using just cable sleeves.
When you say cable sleeves, do you mean like could you talk more about the cable sleeves are?
Yeah, sure. So, well, the cable sleeves themselves are just a material that goes around the cables to protect them. And initially, we used um, plastic cable sleeves. I think it was like something rubberized. And now we use the most used textile sleeves, cloth ones that protect nicely, hide, and look good when it comes to aesthetics. And they also are able to be heated up and stay in the shape that they were heated up. So they would do the loop method. And when it came to contracting, they would just roll one over the other.
Yeah, with all of these, like one other question I had, what all these different subsystems on your robot, how do you go about optimizing each subsystem and making sure that you have only what you need and not any extra? Like I remember last year seeing many robots with um, just simple designs that accomplish the similar task to like what our robot did. Like they'd have one servo to grab the cone and just one servo to manipulate it. How do you guys, or do you guys go about optimizing each subsystem to use as minimum parts as required?
So we wanted to stick to the KISS principle ever since the season started. And I mean, looking at the extendo, it doesn't really look that simple. But we did sacrifice on the wrist initially. We thought of it and we were like, maybe it's not gonna be that useful. And we did try to use as simple solutions the simplest solution that we could find for each mechanism. For example, when it came to the intake, we didn't want to guide the pixels a lot because that would have required more axles, more rollers. We wanted, well, initially we didn't have the folding intake too, and that proved to be a bad idea when it came to intaking from the stacks. And also, we didn't know how to do the climb, and we did the climb mechanism after we made the robot. We CNC'd the parts and assembled it. We did want to use two hooks that we would just leave on the truss and then pull on a hook on a winch. And then we came up with the idea of why not just place a hook on the outtake and climb with that, and that proved to be a really good idea. So we did want to use the simplest solutions where you could find, and it proved to be a good idea because it increased reliability, made quality of life changes when it came to programming. It was easier and more precise.
Yeah. I think something that we were trying to do since the beginning of the season is how we can be as precise as we can with every single subsystem. So just having really optimized subsystems for us was the way to go. So with our intake, we have a couple, like we have multiple linkages and we have multiple rollers as well, and it transfers really well into our outtake. And then with our outtake, using that, like I think we are using axons for almost the first time this season, after
Yeah.
stage, and they're really powerful and just amazing to use. Um, so I think those are some additional benefits that we've had. Um, and sort of wrapping up this episode, what was like the most? What would you say is the most innovative part about your robot, and how have you guys been able to consistently improve on it this season?
I want to say the most innovative system has to be the claw. It's just initially it was such a simple design, and it proved to be just so precise, versatile, easy to implement and use. And I just think being so simple, how can it be this good? But then yes, we did improve it by adding single drop. So instead of using one axon max that would do something similar to the Rooney claw with the two fingers, we put each finger on an axon micro, so that let us single drop. And we are using an over center method as Wolfpack and Don't Blink did in Power Play, so that the claws just don't push the pixels one into the other. They push it into the claw's arm, and then the wrist added at the end. So it did prove to be one of the simplest solutions and just precise, fast, efficient, reliable.
Okay. And I expect sort of now like talking about worlds and your team's journey this season. How have you guys been able to sort of fundraise and just been able to take care of your team as a whole this season?
Hi. So throughout the seasons, this is our fifth season, and throughout the seasons, we really tried to introduce first to our community. And this season, we really that was our priority, to introduce students, to introduce schools, and our entire community to first, and the local authorities to First Tech Challenge and our activity. And when we found out that we are going to Worlds, it was really easy for us to call out for sponsors and our community. So we are going to Worlds with the financial support from our mayor and our local authorities and sponsors, local sponsors. So it was fundraising wasn't the mark. It wasn't just my job. I'm on marketing. It wasn't only my job. It was the entire team job. So every member tried to bring a sponsor to the team and make our travel to Houston possible. So it was really easy for us to access and contact sponsors and our local authorities, and yeah, we really appreciate it.
And like throughout the season, how have you guys been able to maintain contact with your sponsors, as well as ensuring your team is developing as a whole? So this doesn't have to just be with like robot, but with their presentation, and sort of their understanding of First Tech Challenge.
So we really had, I'd say we had many activities that were for the community and with the community. We partnered with our county library. So we had like a sort of a robotics in nature. So we went in a park, and we had our a part of our field, our playing field, our robot, and there were present kids from 5th grade to 11th grade. So our team doesn't only have high school members. I'm in 7th grade. Rami is in 7th grade. So we are really young, and our team focused on inclusion. So that's what we wanted to do with our activities. And in robotics in nature, we had really young kids. So what did we do there? We really introduced them to FIRST. Like we took it from zero and talked about FIRST values, what we do in First Tech Challenge, how's our experience as a Romanian team in Romania, how it's going to First Tech Challenge, how it's organized, how we organize as a team. We organized the league meet in our city alongside two other teams, team 19060 and 15996. So two other teams from our city, and this was really nice for us as a team to. It was a team building, I'd say, a team building activity, and it was really challenging for us to organize a league meet. And at this league meet were present kids from all the schools in our city. So they really had contact with FIRST and saw in person how the matches are played and the teams and the spirit. So I think our league meet was really the perfect opportunity to really introduce our community to FIRST. And organizing this league meet was the perfect opportunity for us to kind of start the season and interact with other teams from our region, and to introduce our local authorities to FIRST.
Nice. Yeah, like I think something that we were trying to do at least this season, and this is also our 5th year as a team, has been connecting with the FIRST community, not just locally but internationally through like these sort of live streams and other initiatives. And now sort of talking about the World Championship next week, what is like one thing that each of you guys are sort of excited about or like want to do in Houston next week?
Well, if you ask me, I'm really excited to interact with international teams and the FIRST community. And I didn't expect to get to Worlds like Petru and Rami. It was their dream, but I didn't let myself dream of Worlds. So the fact that we won and that we are going to Houston and that we as a team get to interact with other teams like from Florida, from Greece, from all over the world, I'm most excited to see the community and to get to know every team and everybody that gets to organize this event, and it's amazing for us. From a small city, in a small country, we are flying to Houston, to America. It's our first time, and it's amazing. And we are really young, so.
If you were to ask me as a driver, I'm really excited for the matches. And since the divisions were out today, I had the chance to do a little bit of scouting and see and analyze all of our opponents and maybe teammates in the qualification matches. And I'm really excited for that, seeing that we are in as I consider the most powerful division in this season.
And finishing off with me, it's all about connecting with other teams. I really want to meet with some teams I've always looked up to and meet the robots they made. And I want to see just the performance overall because I'm more of a technical guy.
I know, at least for me, this is my last season in First Robotics after 8 years. So I'm really excited about seeing not just only what our team is able to do there, but just having fun and making some connections. Because I honestly thought your team was really like a veteran team and experience. I didn't know you guys were like this young, which really impresses me. So I'm really excited to see what other teams are out there like you guys, and we can't wait to make those sort of connections for seasons to come.
Wow, it's your last season, so that must be emotional.
Yeah.
For me and Rami, it's our second season in First, and for Petru, it's, I think, his third.
Yes, it is my third.
So, and as I said, it's our first time going to Worlds, and we didn't expect that. It was sort of our alumni members' dream. So yeah, going to Worlds and having this experience, and we are staying in Houston for 2 weeks, so we really have time. We are leaving not tomorrow, the day after tomorrow.
Oh wow.
Yeah, so we're excited, but yeah, it's really important for us to connect with other teams, and yeah, we want to see what's going on with FRC, FLL, and it's really big for our country. It's really big for our city, and it's our first time. So in our city, we are the first team that is going to Worlds in our city, in our county. And we are the youngest from Romania that's going to Worlds ever. So it's really important for us, and it was important for our community. And yeah, we are really going there proud and not stressed. Like, I'm not stressed. You can ask the drivers and the mechanics, but I'm not stressed.
The stress is real.
Yeah.
Yeah, for me, it's the judges and the engineering portfolio and the interviews. I'm stressed about that, but that's gonna be ending in the first day.
Yeah.
Like the interview, and then I'm gonna have fun. I don't know about my driver, but I'm gonna have fun.
Yeah. Because it's your first time going to Worlds, if you have any questions about what to expect, any questions about Worlds overall, you guys can contact us. The FTC Discord is also very open, and are willing to answer a lot of questions. But sort of to wrap up the episode, what is your team's favorite moment this season, and why?
I think the end of the national championship, when in the finals and the semifinals, we decided not to play the second match and to let WhatsApp and TechnoZ play, because they were, I think, the most feared alliance until the national championship, having the world record at the regionals and having such good chemistry between them. So we decided to let them play, and in the end, when we when we saw on the scoring board that our the Blue Alliance won, it was a wonderful moment for our team. Seeing that our dream from the last seasons has finally became reality.
And I may add, Rami and Petru are members of the Drive team. I'm not, and my other colleagues that are watching this, we are like sort of the public. We are there to encourage the Drive team and the driver. So, seeing that Blue Alliance won and being there together, like we were all together at the playing field, and we were all expecting the results and experiencing that moment that we didn't know how to react. We didn't know how to be happy about this. Like in our mind, this was crazy. Like we were going to Houston for the first time, and I looked at my colleagues, they looked at me, and we were all sort of like, what's going on? And of course, we ran to the lines, to TechnoZ and WhatsApp, and we all hugged each other, and we sang We Are the Champions from Queen. So, winning the nationals and experiencing this with our friends, it was really, that was perfect. And we are waiting for Worlds, and we are waiting to see what Worlds bring for us.
Oh, thank you guys so much for joining us today, and good luck at Worlds, and we'll see you in Franklin.
Yep.
Cannot wait. Thank you so much for this opportunity.
Thank you.
And can I see you there?